All right, this is chapter 10, section 3, circles. Our learning objectives are to write and graph the equation of a circle, to find the center and radius of a circle, and use them to graph a circle. So, firstly, just so that you guys have the proper definitions, because I don't want you running around on the street not knowing proper items. The word circle, as we're going to use it, is the set of all points in a plane at a distance r, which is the radius, from a given point. The center, and I put here in parentheses, of a circle. The center of a circle is the point that is the same distance from every point on the circle. So really what we're looking at here, two words come up twice in these definitions. So in circles, we are caring about the distance. And if you look at radius of a circle, the radius r of a circle is the distance between the center of the circle and any point on the circumference. So here's that word again, the distance. And in fact, we get the standard form of a circle from the distance equation, so the standard form of a circle with the center h comma k and radius r is x minus h squared plus y minus k squared equals r squared. And an example is this guy right here, x plus 4 squared plus y minus 3 squared equals 16. In this scenario, so if you overlay the standard form, on our example, then we have a vertex of -4, 3, and we have a radius of 4. All right, so let's look at how these problems are going to look for us. What is an equation for each translation? So we start out with x squared plus y squared equals 1. When you see it like this, you know that the vertex is at 0, 0. When I'm not plusing or minusing anything inside that x squared or the y squared. So we are going to move this guy left 5 units and down 3 units. So let's open up. We're going to take that vertex and then in this case our radius is 1, so we'll continue. Our radius is going to stay the same. We are just translating the vertex. Okay, so if I look at my x, if I want to go left 5 units, it's always the opposite. When I'm thinking of a grid, usually right is positive on the x and left is negative. But in the equation of a circle, it is opposite. So if I want to go left 5 units, that's going to be a plus 5. And for the y, if I want to go down 3 units, it's again opposite. So normally down would be negative and up would be positive, but inside these parentheses, everything is opposite. So if I want to go down 3 units, we would go plus 3. So let's try that again with x squared plus y squared equals 9. The radius is 3, and because we're just translating, it's going to remain 3. My vertex here is, again, at 0, 0, because there's no adding or subtracting next to the x value or the y value. So we're going to open up our circle equation. The radius remains the same, it's 3 squared or 9. And we're going to go right 2 units. Right is normally positive, but we are all opposite inside these parentheses. Up is usually positive, so inside the parentheses you're going to go opposite. All right, so when we're talking about transforming a circle, which is one of our key concepts, we can use R to stretch or shrink the circle. So if we have x squared plus y squared equals 1, all we have to do is change the radius, either make it bigger or smaller, and we can stretch or shrink the circle. If we want to move it right, left, up, or down, we can take our equation of a circle with center at center 0, 0, and all we have to do is take the opposite of where we want our circle to be centered and throw it into this equation, x minus h squared plus y minus k squared equals r squared. So to translate it, we just subtract from the inside of those parentheses. All right, so let's see how translations can affect real-world scenarios. What is an equation for a circular irrigation field that has a radius of 12 and a center at 7, negative 10? So we want to, for A, we want to write the generic equation, which is x minus h squared plus y minus k squared equals radius squared. And now let's just fill in the blanks. H is 7. K is negative 10, so you go y minus negative 10 is plus 10. Is equal to 12 squared, but we know that 12 squared is equal to 144. So while you guys are finishing down, let's look at the reasoning question. Will the graph of every equation of the form x minus h squared plus y minus k squared equals r squared, where h, k, and r are real numbers, be a circle? Explain your reasoning. Is there ever a scenario, as long as h, k, and r are reals, where items won't be a circle if we plug it into the equation? So if you think about the nature of this equation, I've got a squared value, so we're squaring everything. So it's not like I'm dealing with square roots or denominators where I have to be cautious of negatives or zeros in the denominator. So truly, it should always, if it follows this form, it should always be a circle. Okay, so that seemed a little too easy. So let's see how hard this is going to get for us. What are the center and radius of the circle with the given equation? So I'm going to write down the generic form. and we're just going to do a nice across-the-board comparison. So in this case, h is going to be negative 8. K is going to be negative 3. And r squared is going to be 121. So the vertex is at negative 8, negative 3. And the radius, well, we know radius squared is 121. So our radius is the square root of that, which is 11. And remember, in this scenario, normally when we take the square root of both sides, we have a plus and a minus, a negative answer. We are ignoring the negative answer because you cannot have a negative radius. A radius is a distance and it's positive. So we've highlighted the word distance in all of our definitions from the last page. That's because it kind of deals with the radius scenario. So we are completely ignoring the negative version of that. All right, so a little bit harder, tiny bit, baby bit harder. If you look at this equation up here, it is not written in this nice format. Darn you, book. So we have to complete the square to get it to be in standard form. So we're going to group our x's together and our y's together. And then we are going to make room for when I complete the square. Here's where I complete the square for the x's. Here's where I complete the square for the y's. And then I have to add it to the others. I had to add both. If I'm adding a number to one side of the equation, I have to add it to the other side as well. Okay, so we're completing the square. We're taking our b value. We are dividing it by 2. And we're squaring it. So for my x's, it would be negative 6 divided by 2 is negative 3. And then I square that and I get positive 9. I have to add it to both sides. Because it's a balancing act, you got to keep it equal and equal. My y's, I'm going to take my 14 divided by 2 and square it. 7 squared is 49. And this would be 49. That's a 49 inches. Alright, so I've done my accounting. I've added what I add to the left side, I add to the right side. So now I can write these as, this is x minus 3 squared. This is a y plus 7 squared. 8 plus 9 is 17, and plus 49. $66. Do my math right on that. 8 plus 9 is 17. 17 and 49. 16 carry the 1. 66. Phew. Okay, so now we can identify the center and the radius. My vertex here is going to be opposite of minus 3, which is 3. Opposite of plus 7, which is minus 7. And my radius is my radius squared is 66. So my radius is root 66. Root 66! Oh gosh. So I've been saying vertex and it's actually the center. So let me change these guys.
Oh, the B's are actually vertices.
Yeah. They're centers.
Okay, well, how do we mark centers?
With a C. So we're just going to change these B's to a C. I've been saying vertex because we did parabolas yesterday. So we're just gonna change that to mostly. So here's the graphing component. When we our learning objectives were to identify the center and radius of a circle in the equation. And so here's the graphing component to that learning objective. So our center is going to be the opposite of what's inside with x and y. So this is -4, so our center is going to be at 4, comma, -2. And our radius is going to be the square root of 49, which is 7. So once we know the center and the radius, it's really easy peasy to graph. So my center is at 1, 2, 3, 4, -2. So here's my center. And I'm going to go north, east, west, and south 7 units. So I'm going to go north, 1, 2, 6, 7. Go south. 6, 7. Gotta mark my center a little better. 1, 2, 3, 4, 5, 6, 7. Go west, and now I'm going to go east. 1, 2, 3, 4, 5, 6, 7. So once I have all those points, north, east, west, and south, I can connect them with a smooth curve. All right, so once you have it in standard form, you can easily pull out the center and the radius and graph it.
Alrighty.
That's it.